Hello guys, what's up and welcome back. Here's your guy Emmanuel, and in today's part of the course we're going to be seeing how to create Docker containers. But before we can start creating Docker containers, we first of all have to understand what is an image, how to create a container from an image. Then we're going to proceed to understand the Docker architecture. That is what happens with Docker when you actually create a container. So let's start by understanding or defining what an image is. According to this definition, a Docker image is essentially a lightweight standalone package that contains everything needed to run an application in the form of a container. That's kind of what an image is. So I want you to think of an image as a template or a blueprint for creating containers. And if you don't understand what I mean by template or blueprint, let me put it this way. Let's say you want to make pizza. In order for you to make pizza, you need some recipes in order to make pizza. So I want you to think of the recipes of pizza as an image, and I want you to think of the actual pizza itself as the container. So basically, an image is what you use to create a container. So if an image is what you use to create a container, what is this image made up of? The first thing you would find in an image is the application code itself. That's the very first thing you'll find in an image. The second thing you'll find in an image is the runtime environment. This can be Node.js, it can be Python, it can be the runtime for Java, whatsoever. But you'll definitely find that in there as well. The third thing you would find are some system libraries and dependencies. Then the fourth thing are configuration files. And the last thing you'll find in an image are environment variables. So without taking much of your time, let's go and create our first container. As I said, in order for you to create a container, you will need an image, right? And as you know by now, an image is what contains everything that you need to actually create a container. Now let's say we want to create an NGINX container. That's just an example. I'm going to check if I have the NGINX image to create that container. And in order to do that, you can use the command docker images like that, and you hit enter. As you can see, I don't have any image right now on my local machine. So how do I create a container if I don't have the image on my local machine? So there are two things I can do right now. The first is I can download that NGINX image that I'm going to use to create the NGINX container from a public Docker image repository like Docker Hub. Or I can just go straight and run the command to create that container, and Docker will take care of downloading that image. I will go with the second option. I will just go straight and write the command to actually create that container, and I will let Docker download the image for me. So the first thing I'm going to do is I'm going to do Docker container run, and I want you to note that you can also use the old command, which is just Docker run, and it's still going to work. But in this specific case, I'm going to use modern commands, which is Docker container run. Then the next thing I'm going to do is I'm going to do a -p flag, which means port, and I'm going to specify the port, which is 80. Then I'm going to specify a name, and I'm just going to call this my NGINX, and I'm going to specify an NGINX image or the name of the image I want to use. In this case, it would be NGINX, and I will hit enter. So the first thing I want you to notice here is that Docker tries to check for that NGINX image locally, but cannot find it because we don't have it. Then it returns this message that unable to find image NGINX latest locally. So Docker then proceeds to download that image from a public repository like Docker Hub, which is advantageous because we don't have to download the image, then use it to create a container. Docker will take care of downloading that image for us. Now let's go check and see if our NGINX container is running. So I'll come to my browser and I'll put in localhost 80 and I will hit enter. And as you can see, it says welcome to NGINX. This shows or proves that our NGINX container is running. And if I minimize my browser and I just keep refreshing, on the left side, you're going to see some container logs, right? Let me refresh more. you're going to see some container logs. But the first thing you're going to notice is that we cannot more do anything on this terminal, right? Like for example, let's say I want to stop the container, or I want to see how many containers I have, or I want to go into this specific container. I cannot do it at the moment. Why? Because this container is not running as a background process. Instead, it's attached to my terminal. So because of that, I cannot use this terminal. And if I attempt to regain my terminal by doing a Control-C, you're going to notice that this container will stop running. So if I refresh my screen, boom, the container will stop running. So how do you solve this problem? You solve this problem by running your container in a detached mode. And I'm going to show you exactly how to do it. So we are going to do a Docker container run, and I'm going to do a -D. So -D stands for detached mode. So basically I'm telling Docker that, hey, run this container in the background. So I'll do a -D, I'll do a -P, then I will do 80, then I will specify a name, that's --name, and I will just call this my website, and I will specify the name of the image, right? Now the question is, why did I not call this my NGINX? Let's try. Let me call this NGINX, my NGINX, like the previous container, and I'm going to do this would be an NGINX image again. So I'm going to do NGINX, and I'm going to hit enter, right? So there is an error. Now I want you to read the error. It says Docker error response from Daemon. It says conflict. The container name my NGINX is already in use by container, and they provide the container ID. You have to remove or rename that container to be able to reuse that name. So the reason why we're getting this error is because we previously created a container called my NGINX, and that container is still on our local machine, even though it is not running, but it's still there. So because of that, we cannot use that same name called NGINX. That's the reason why I renamed this to my website. I'm going to hit enter. Now you're going to notice that our container has started, and now you see we have our terminal. And if I go back to my browser and I do localhost 80, I do localhost 80, you should have NGINX right here, and I can refresh as many times as I want, right? Now that we have our container that's running, I can actually see this container. So in order for you to see a container, you can just use the command docker ps. You're still going to see that container, or you can use the command docker container list, and you're still going to see that container, right? So both commands work. One is old and one is the modern way of running Docker commands. This is the modern way of running Docker commands, right? So let's see. I'm going to do again, I'm going to clear my entire screen, clear, and I'm going to do a docker ps because it's short. And as you can see, this is my container that's running. So you have the container ID, you have the image that this container is using. In this case is NGINX. You have the command, you have when it was created about a minute ago, you have the status of the container, it's up about a minute ago, then you have the port 8080, and you have the name of the container, which is my website. But one thing you're going to notice here is that we don't just have one container, we have two. So why am I saying just one? And moreover, how do I even know that we have two containers? So if I run the command docker info, let's see docker info, and we go to server, then we go to containers, you're going to see that it says we have two containers. We have one that's running, we have 0 that's pause, and we have one that's stop. Means we have a container that's stop. But why are we not seeing the stop container? When I do a docker ps, why is the stop container not showing up? The reason is because docker ps only shows you containers in the running state. So if you want to see pause or stop containers, you then do a docker ps-a, and now you will be able to see all of your containers, including containers that have been stopped and containers, that have been paused, right? In our case, we can see two of these containers. Now, before we continue exploring that container, it is important for us to understand the command we just used, right? And here's the command we just used: docker container run -d -p 8080 -name my website, the image name NGINX, right? So what does this command mean, right? What does this 8080 here means? That's very, very, very important, right? Now we already know the -d means detached mode. It means run the container in the background rather than attaching it to the terminal, right? And we saw exactly how that works. The -p P means port, and this entire part here is what they call port mapping. So what does the 8080 here means? So the first thing I want you to understand with port mapping is that there is something called the host port and there is something called the container port. So this number here, this 80 here is what they call the host port, and this other 80 here is what they call the container port, right? As I explained it here, the host port is the port on your local machine or server. This port right here, this first port, which is port 80, is the port that's running on my local machine. In this case, I'm creating these containers using my laptop. So this port called port 80 is the port that's on my laptop. But now the container port, which is also 80, is the port on your container. Yeah, I don't know if that makes sense. So let me explain what just happened. So when we ran this command, we basically told Docker that, hey, we want to create an NGINX container called my website in a detached mode with the port mapping 8080. And we already said the first port is the host port, the second port is the container port. Now I want you to understand something. NGINX listens, right? The NGINX service or the NGINX container by default listens on port 80. That is, the container port is port 80. So we're going to create another container, and I'm going to say docker container run -d, right, -p, and I'm going to do 80 map to 80 --name. I'm going to do NGINX demo, and I'm going to do NGINX right here, and I'm going to hit enter. So as you can see, our second container has been created, or our third container has been created. And if I do docker ps, we should see that we now have two running containers. One is my NGINX demo, the one that was just created right now, and the first one here is my website, right? So if I come to my browser and let's say I want to access this NGINX container right here, I will do localhost. Instead of saying 80, I will do 8080. And when I do 8080, I'm trying to access this NGINX container that's named NGINX demo. But if I do localhost 80, I'll try to access this other container that's listening on port 80. Now, what's important for you to remember is that both container ports for NGINX demo and my website are the same. They're both 80, but the host ports are different. One is using the host port of 8080 and is forwarding the traffic to the NGINX port 80, while the other is using the host port of 80 and is forwarding the traffic to the NGINX port, which is the container port of 80. So what I'm trying to make you understand here is that host ports can be different, but container ports cannot be different. That's just what I'm trying to make you understand here. Right? Now that you understand the difference between host port and container port, the next thing I want us to do is to explore these containers. Now, let's say I want to see some container logs. I want to see, what's happening with this container. I can just do a docker logs and I will specify the ID of the container. Now, you can specify just the first four letters. You can do 7733 and you hit enter, and it's going to give you some container logs right here. So these are the logs of the container, right? Now, but what if I want to go into this container? So let me do a docker ps, and let's say I want to go into this container right here. So I'll use the command docker exec, right, -it. Then I'll specify the container name. You can also use the name or you can use the ID. In this case, I'll use the name, and I will specify the type of shell that I want to use. So I want to use -bin -bash, and I'm going to hit enter. So now you can see that I'm inside of that container, and I can do things like LX. So you can see I'm right here. While I'm in here, I can cd into, let's say, home, right? So I can do a cd to home. I can do a LX. As you can see, there's nothing. I can go back and I can cd into, I don't know, anywhere. I can literally go anywhere I want to go right now, right? I can cd into, let's say, so I can do an LX. yeah, there's nothing as well. So I can go back and I can make some changes, right? I can add files, I can, delete files, I can modify this file system, I can, do whatever thing I want to do. And now let's say I want to leave this container. Just simply do an exit, and now I'm back. And if I do a docker ps, I should see all my running containers. And if I do a docker ps-a, I should see both my running container and stopped, containers right here. So the next thing is, how do you stop a container? Let's say I want to stop this container. So I want to stop this container called NGINX Daemon. In order to do that, you just do a docker stop, and you will specify the container ID you want to stop. In this case, 7733, and I'll hit enter. Now, if I do another docker ps, you're going to notice that I already have one container that's running. And if I do a docker ps-a, you're going to notice that I have two containers that have been stopped. This one right here and this one right here. And I already have one container that is running. So let's say I want to start that container back, right? So you just do a docker start and you specify the container ID 7733 and you hit enter. Then if I do a docker ps, I should now see that I have two containers that are running. Now let's say I want to delete a container. So you will do a docker remove and you would specify the container ID, in this case 7733, and I'll hit enter. Now I want you to note something. It says that cannot remove container is running. So here's the thing, you cannot remove a running container, cannot delete a running container, right? So you first of all have to stop that container before you can delete the container. But we already have a container that's stopped. So let's try to remove that stop container, which is this container right here. So I'm going to do a docker remove, and I'm going to specify the container ID, which is 7f9c, and I'm going to hit enter. Now if I do a docker ps-a, you'll see that we don't more have that container, right? What if you want to remove a running container but you don't want to stop it? So you just do a docker remove -f, that's forced, and you will then specify the container ID like that, and boom, it removes the container. So if I do a docker ps, you see I now have just one running container. And if I do a docker ps-a, you see I already have one container. Why? Because my two previous containers were deleted. Now let's say you want to see the images that you have. So if I do a docker images, I hit enter. So as you can see, I already have one image right here, and that is the NGINX image. Now let's say I want to delete this image. So I'll do a docker remove image now with an I, and I will specify the image ID. So I'll just copy this image ID and I'll specify that image ID right here, and I'll hit enter. Now you see that the image cannot be removed, and the reason the image cannot be removed is because the image is being used by a running container, and this is the ID of that container. So if I do a docker ps, you're going to see that this container ID right here matches this container ID right here. So you cannot delete or remove an image that's been used by a running container. But the question is, can you delete or remove an image that's been used by a stop container? Let's try it out. Docker stop, and I'm going to specify the container ID. That'll be an A436. I'm going to hit enter. So that container has been stopped. So if I do a docker ps, you won't see any container. Then if I do a docker ps-a, you're going to see we have one container with status exited, meaning it's stopped. And if I try to remove that image one more time, so I do a docker remove image and I specify the image ID, which is this one right here, you're going to notice that it says image cannot be removed because it's being used by a stopped container with container ID this. So meaning that if you want to actually delete an image, you have to make sure that that image is not being used by any container. So let's go and delete the container. So let's do a docker. Let's start this container back. So I'm going to do a docker start, and I'm going to specify the container ID. So that will be A436, and I'm going to hit enter. Now if I do a docker ps, you're going to notice that the container is running. Now let's delete this container. Now remember I said earlier that if you want to delete a container, you first of all have to stop it, right? In this case, we don't need it. So we're just going to do a docker remove -f, that's forced, and we're going to do a for 4 and A for 3, 6, which is the container ID, and we're gonna hit enter, and that container will be deleted. So now if I do a docker ps -a, you're gonna notice that we don't have any container. Then if I do a docker images, you're gonna notice that we have one image. Then if I do a docker remove image, and I specify the image ID right here, and I hit enter, you're gonna notice that now we can now delete that image. And if I do a docker images, you see we don't have any more images. So in this part of the video, I've showed you how to create containers, how to see the logs of a container, how to go into a container, how to exit out of a container, how to stop a container, how to start a container, how to delete the container, and also how to delete an image. Now let's go back here and let's do something. Let's create that container one more time. So I'm going to do a docker container run. In this case, I'm not going to do a docker container run. I'm just going to use the old command just to show you that it still works, right? So I'm going to do a docker run -d, so it runs in a detached mode, -p, and I want to open a different port on my server, right? Let's say I want to open port 9000, for example. I want to open port 9000. That will be the host port, and the container port will be 80. I want to do a name, and I'm just going to call this final website. That's how I'm just going to call it, right? And I'm going to specify the image that I'm going to use. In this case, it would be NGINX, and I'm going to hit enter. So the first thing you notice here is that it's unable to find image NGINX latest locally. Why? Because we deleted that image, so that image is no more present on our local machine, right? And then it will proceed to download that image from a public repository called Docker Hub. We're going to explore how to use Docker Hub. Then it now uses the image to create a container, and here's the container ID. And if I do a docker ps, I should see that we now have a running container right here. Now if I go to my local machine and I do a local host 80, you'll see that we are unable to access NGINX, right? And if I do another local host 80, you also notice that we are unable to access NGINX. But if I do a local host 9000, you'll see that now we are able to access NGINX. Why? And the reason is because we specified our host port to be 9000, right? We didn't specify 80, we didn't specify 80, we specified it to be 9000. And now this takes us back to what I was talking about. You can set your host port to be anything, but your container port cannot change. It's actually the port on which the service is listening to, right? I hope that makes a lot of sense. So what I want us to do now is I want us to understand the Docker architecture. That's what happens in the background when we actually create a Docker container. So the first thing is that Docker works using a client server architecture with 3 main parts. And we've talked about this client server architecture in the past. Remember when we ran the command docker version, we saw client, we saw server, and we said client is just basically a CLI where you will give commands, then Docker will pass these commands over to something called the server. Then the server is kind of what is responsible for executing the job, right? So it's important for you to understand that Docker works using a client server architecture with 3 main parts, right? So the first part itself is the Docker client. The second part is the Docker Daemon, or they call it Docker D, and the third part are the Docker objects. That's the image, containers, volumes, and the network, right? Now the Docker client, as I said earlier, is the Docker CLI. So it collects commands and it passes those commands over to the Docker Daemon. Then the Docker Daemon is kind of what is responsible for creating the container. So it kind of runs processes that are responsible for creating the container, right? So this is kind of how it works. So you're going to have a Docker client. In this case, the client can maybe be on your laptop. In my case, it's my laptop, or it can be on an enterprise server. Then you're going to pass over a command to the client. In this case, docker run -d -p 8080 NGINX or whatsoever. Then what will happen is the client will take over that command and we pass that command over to the Docker Daemon, right? Now, when it passes the command over to the Docker Daemon, what happens happens? In our case, let's look at what happened, right? So here we told Docker that we want to create a container called final website using the image NGINX. So we did a Docker run -d, which stands for detach mode. Then we do a -p for port mapping, and we opened port 9000 as our host port, and we specified the container port as port 80. Then we used the -- name flag to specify the name of the container, which is final website. Then we told Docker which image to use, which is NGINX, right? So that's what we did. That's the command we ran. So what happened was that the client will then send a request to the Docker daemon or the server via a REST API, right? And the daemon is kind of what does the real work. It runs in the background, so we technically can't see it, right? Now, what will the daemon do? The first thing the daemon will do is that the daemon will check for our local system. And why is it doing that? Why is it checking? It's looking for this image. So that's the first thing the daemon does. The daemon tries to find the image that we've specified. In this case, we've specified that we want to create a container and we want to use an NGINX image. So the daemon tries to find that image. And what happens is the daemon is unable to find that image. So that's why, this message is returned here that, hey, unable to find image, right? Locally. Now, if the image was present, the daemon goes ahead and it uses it. So for example, let's say I want to create another NGINX container really fast. I'm just going to call this demo and I'm going to hit enter. So let's see, the port here. I'm going to do demo 1 and I'm going to hit enter. Cool. So the container was created, right? Now, I want you to pay attention to something. In the case of the second container that we've created, the container was created automatically. Why? Because when the request was sent by the client to the daemon to create the second container, the daemon did check if the image was already present locally. It found it and it used it to create a container. In the first scenario, the image was not present locally. So what it did was it had to download that image. So it pulled the image from Docker Hub. Now I want you to also understand that it must not always pull that image from Docker Hub, right? It can also pull that image from somewhere else. It can pull it maybe from a GitLab repository. It can pull it from a repository on AWS. It can pull it from anywhere as long as you specify where it should go and pull that image. But in our specific case, it's pulling the image itself from Docker Hub, right? Because that's kind of the default repository, right? Then it now uses the image to create a container. That's kind of what happens. Docker will then set up some sort of namespaces, which I don't really want to go too much into detail regarding that. And at the end of the day, we're going to have our container. So that's kind of how Docker works, right? So there's a client and there is a server, and what happens is that the client sends a request to the server using the REST API. The server receives the request, checks if the image is present locally, and if it's not, it downloads that image from a public repository like Docker Hub or whatsoever repository you have specified, and it then uses that to create a container. So that's kind of how Docker works. So guys, thank you for taking the time to go through this part of the course. I hope you now have a better understanding of how to create containers, how to delete containers, how to see containers logs, how to go into a container, how to stop, start and remove a container. And I'll see you in the next part of this course. Bye.